Okay, today we're going to look at section 4.3, logarithmic functions. So we have some conditions to take into account. For x greater than 0 and a greater than 0 and a not equal to 1, the logarithmic function with base a is y equals log base a of x, the domain of x greater than 0. So exponential and logarithmic functions are inverses of each other. So we have this following relationship between the two. If you have y equals the log base a of x, it's the same as saying a to y to the y power is equal to x. So let's see how this works. We have y equals the log base 6 of x. So this is the same as 6 to the y power equals x. Okay, c equals the log base 3 of 5. It's the same as 3 to the c power equals 5. Okay, now we have y equals the log base 2 of 5x. Well, this is 2 to the y power equals 5x. Okay, so now let's go the other way. Write the exponential equations in logarithmic form. So I have m equals 3 to the p. That's the same as saying p equals log base 3 of m. I have 9 to the 2x is equal to y. That's the same as saying 2x equals log base 9 of y. Okay, then we have some properties of logarithms to look at. First one, we have the log base b of m times n is equal to the log base b of m, the log base b of n. Likewise, the log base b of m divided by n is equal to the log base b of m minus the log base b of n. And lastly, this power rule here, we have the log base b of m to the k is equal to k times the log base b of m. So let's rewrite expressions as a sum or difference of logarithms and simplify. So I have log base 2 of 9 times y. That is simply log base 2 of 9 plus log base 2 of y. We have multiplication, so we add. Okay, log base 7 of 2 divided by x. Well, we're dividing. So this is log base 7 of 2 minus log base 7 of x. Okay, now I have log base 2 of x minus 2, or x to the negative 2. So this, we can take this out and put it in as negative 2 times the log base 2 of x. So now let's put it all together. So we have addition, or we have multiplication, we have division, we have multiplication again. So let's break this down to the log of r s squared t minus the log of u cubed b to the 5th. Now you got to be careful on this. So this is the log of r plus the log of s squared plus the log of t minus the log of u cubed plus the log of v to the 5th, because this is multiplication. The thing is, remember, you're subtracting the whole thing at the end. So here, this will stay log r. We can bring down the 2. We have 2 times the log of s plus the log of t minus 3 times the log of u plus 5 times the log of v. And now here's where everybody messes up. I have the log of r plus 2 times the log of s plus the log of t minus 3 times the log of u. Everybody gets that one. And then you forget to distribute it here as well. Minus 5 times the log of v. So be careful. Okay, now we're getting a little messier. So the fourth root is, I'm going to go out this way. Log base m of x to the 5th y to the 7th z to the 9th to the 1/4. So we can do this 2 different ways. We can go ahead and bring out this 1/4. And then we can do log x to the 5th, or log base m x to the 5th plus log base m y to the 7th minus log base m z to the 9th. Okay, leave this 1/4 out here. So I have 5 times the log base m of x plus 7 times the log base m of y minus 9 times the log base m of z. Then I multiply the 1/4 and I get 5/4 log base m of x plus 7/4 log base m of y minus 9/4 log base m of z. Okay, so now we get a real fun one here. I have multiplication here. I have log of the cube root of 2x squared minus 5 plus the log of x minus 4 to the 5th. Okay, and I'm going to work this way. So this is 1/3 the log of 2x squared minus 5 plus 5 times the log of x minus 4. Okay, so bring down our 1/3. I have the log of 2. Oh, I can't do anything with that, can I? So it's simply, this is it. 1/3 the log of 2x squared minus 5 plus 5 times the log of x minus 4. None of the rules apply. There's nothing further we can do. That is it. Okay, now we're going to go the other way. So I have 2 times the log of x. This gives me the log of x squared plus 3 times the log of y is the log of y cubed. Then I'm adding, so this is simply the log of x squared y cubed. Okay, here I have 1/2 times the log of a. So that's the log base a to the 1/2 minus 9 to the log of b, which is log of b to the 9th. We have subtraction, so this is the log of a to the 1/2 over b to the 9th. And that is it. Okay. Okay, let's see what we got going on here. So this is the log base 3 of x to the 7th plus the log base 3 of y to the 5th minus the log base 3 of z to the 8th. So we have addition. I have log base 3 of x to the 7th, y to the 5th, subtraction, divided by z to the 8th. Here, I believe this is a typo. So here, I can't really do anything with this right now. Here we have minus log of y plus 3 to the 1/2, which we can say square root, right? So here I have the log of 2y plus 5 over the square root of y plus 3. Couple more properties here. The log base b of 1 is 0 because b to the 0 power is 1. And the log base b of b to the x is x. So let's see. Log base 5 of 1, well, that's 0. Log base 6 is 6. That's 6 to the first, right? Which is 1. The log base 4 of 16, which is what? The log base 4 of 4 squared. So that's 2. Okay, now we'll look at graphs. And you may notice something looking at these. Characteristics of the graph of the parent function f of x equals log base b of x. For any real number x and constant b greater than 0, where b does not equal 1, we can see the following characteristics in the graph of f of x equals log base b of x. It is 1-to-1, has a vertical asymptote at x equals 0, has a domain of 0 to infinity, has a range of negative infinity to infinity, has an x-intercept of 1, 0, and a key point b1, no y-intercept, increasing for b greater than 0 and decreasing for b between 0 and 1. So, for any constant, c, the function f of x equals log base b of x plus c, just the parent function, left c units if c is greater than 0, and right c units if c is less than 0. In other words, in the opposite direction of c. Has a vertical asymptote of x equals negative c, and domain is negative c infinity, and range is negative infinity infinity. And secondly, for any constant d, function f of x equals the log base b of x plus d, shifts the parent functions y equals log base b of x up d units for d is positive, and down d units for d less than 0. Again, vertical asymptote is x equals 0, Domain is 0, infinity. Range is negative infinity, infinity. So looking at these graphs, you'll note, if you remember from last time, what we have. Yeah. These are inverses, which we stated. So let's look at what we have here. State the domain, range, x-intercept, and the vertical asymptote of each function. So we're starting off with basic, very basic. So we have vertical asymptote, x equals 0. We have a domain, 0 to infinity. We have a range, negative infinity to infinity. Domain, range, x-intercept. Our x-intercept is 1, 0. So now what do we have? We have within the parentheses, so 5 units, 5 is positive, so we're shifting left 5 units, which means our asymptote is x equals negative 5. Our domain is now negative 5 to infinity. Our range is still the same, negative infinity to infinity. Oh, wait a minute. D units, we're going up and down. No, C units. That's correct. Got that, got that, got that. What is our intercept? And is this equal to 0? Well, we need to move left 4. So x-intercept is at negative 4, or left 5. So that's go from a regular to there. Okay, now we're subtracting 4. So that means our asymptote is at x equals 4. Our domain is from 4 to infinity. Our range stays the same, negative infinity to infinity. Our x-intercept will now be moved to the right 4, so that's 5, 0. Is that everything we wanted? Yep. Okay. Graph the following functions by finding the vertical asymptote and plotting 3 points on the graph. Okay. So this is standard. Vertical asymptote is x equals 0. So if I let x be 1, f of 1, log base 3 of 1, well, 3 to the 0 power. So I have 1, 0 right there. What if I let x equal 3? F of 3, I have log base 3 of 3. 3 to the first power, 1. And then if I let f equal 9, log base 3 and 9, I get 2. Looking at this shape. Okay. So here I have x minus 1 in my parentheses. So c is negative. So I'm moving right 1 unit. So that means x equals 1 is this. Okay. So what is f of 2? Well, that is log base 2 of 2 minus 1, which is 0. So I have the point 2, 0. Okay, how about f of 3? That gives me log base 2 of 3 minus 1. Log base 2 of 2, which is 1. So I have 3, 1. And let's go f of 5. Me log base 2, 5 minus 1 equals the log base 2 of 4, which is 2. I have 5, 2. So I have my 3 points. 2, 0. 3, 1. And 5, 2. So that is my graph. Okay, so x minus 3. So we're moving here. Okay, x equals 3. Okay, now let's see. Log base 3 of 4 minus 3 minus 2. So this is 0 minus 2. So I have 3, negative 2. Okay. How about log base 3 of 6 minus 3? Let's subtract 2. This is 1. So I have 6, negative 1. And if I go log base 3 of 9 minus 3, that doesn't work. So let's see where we got. We had 3. That can't be right. Because that's 4, not 3. 4, negative 2. 6, negative 1. And we can get the basic idea how this looks. Okay. So that is it for this section. Have a good day, and I shall see you next time.